All right, so you might be having some issues whenever it comes to converting a regular probability to its CDF function, all right? It's CDF property. So it's a CDF means cumulative distribution function, all right? So the word cumulative means we are gathering the probabilities together, so we're adding them up, all right? So I developed a formula back in 2024 when I was helping some of my quantitative method students to actually understand this topic. Like I went on YouTube, I went into some textbooks and the formula wasn't there. So I created 4 different rules and I'm going to show you guys how to understand these rules. All right, so I'm going to have the first one on the screen and give you an example to ensure that this rule is clear and concise. So here we have the probability. Here, I label my interval values, the lower and the upper one. I use A and B, so common terms are arbitrary values that we normally use in mathematics. All right. So this no, I said no, this is equal to the probability no. So f of b, that's a cumulative methodology. F of b minus f of a minus 1. That is how I coined this first rule here. So I'm going to explain this to you with an example because it's saying, what is this here? This property that I developed. What is this saying here to you? So we are including, so x, let me tell you how this inequality is read. So x now is less than or equal to the value of b, while x is greater than or equal to the value of a. So let me show you something here. So if 5 is less than 9, it can also conversely be said 9 is greater than 5. All right, it's the same procedure here. So let me give you guys an example here. Let's say on your exam, you see this question here. You say 2, so x greater than or equal to 2, while x is less than or equal to 4. All right? So in probability, we start accounting for values that are from 0. So we have 0, 1, 2, 3, and 4 here. So this equal sign means we're including the value of 4. So we want to find the values of x, the probability values of x that are less than 4, and they are also greater than or equal to 2. So because they are greater than or equal to 2, we're excluding the probability values of x equals 0 and 1. So if you add, so the probability of x equals 0, what's the probability of x equal 1? That is the same thing as saying f of 1. So we're excluding f of 1. And excluding means in a mathematical sense, we are subtracting f of 1 from f of 4. Because we're including this, that means right, this equal sign means we're including the CDF for this 4 here. So it's f of 4 minus f of 1. This is the first rule. I have 3 more rules to show you. I hope this was pretty nice. All right. I have 3 more rules to show you. The second rule here. So we have here. So A is the lower value in the interval. So x is greater than or equal to A, while x is less than B. All right. So let me show you what I developed for this here. So for this second one here. So this is equal to f of B minus 1 minus f of A minus 1. So I'm going to bring this to life for you guys with an example. Because if I explain to you how I derived it, you won't understand it. So let me give you a simpler way. So same example, we have x is greater than or equal to 2, while x is less than 4. So since x is less than 4, we're not including the value of 4, so we're including all the probability values that comes before 4, starting at 0. So we have 0, 1, 2, and 3. All right, so x is greater than or equal to 2, while it is less than 4. So those values that we're including here are 2 and 3. All right, so we're excluding this 1 and this 0 here. So since we're excluding this 1 and 0, that means we're taking it away. And remember, the probability of x equals 0. The probability of x equals 1. the same thing as saying f of 1. So we're excluding, we're removing it. So minus means we're removing f of 1. So here, the number that comes before this 4 is 3. So that's f of 3 minus f of 1. All right? So I hope that this methodology makes it easier for you guys to understand these questions. So let's move to rule 3 here. So for rule 3 in this case, so we have a here, x is greater than a, while x is less than or equal to b. And the formula that I developed for this one is f of b minus f of 1. So if you see these formulas anywhere else, just know it was the original developed from here. All right, so let me give you an example for this one. So we have 2 here, x is greater than 2, while x is less than or equal to 4. All right, so since we're starting in probability, we start accounting for values from zeros. So we have 0, 1, 2, 3, 4, because we're including the 4 here. But so the value that we're looking for, the values of x has to be greater than 2 and it's less than or equal to 4. So those values would have been 3 and 4 respectively. So we're excluding x equal 1, 2, and 0. So we have the probability of x equal 1 plus the probability of x equals 2 and 0. And that is the same thing as saying f of 2. All right, so we're excluding f of 2. All right, so we're taking away it here. So we are removing f of 2 here. So we're including this 4 here. So write f of 4 minus f of 2. All right, so if this comes back on your exam, rather multiple choice, university level, high school level, PhD, masters, it's the same rule applies. All right, so let me give you the fourth rule. All right, here's the fourth rule. All right, I sat down and I came up with the idea and it just went well. So x now is less than b, while x is greater than a. All right, so let me give you guys the rule for this one as well. Now this is equal to the probability. So f of b minus 1 minus f of a. So I use a for the example here. So a and the b are basically like integers in this case. So it's a discrete probability distribution that we're looking here. All right. So the values can be counted. So this rule won't work for a continuous probability distribution. I'm going to develop one for a continuous probability distribution as well. So let me give you an example for this one here. So we have let's say we replace a now. Replace a with 2 and replacing b with 4. So x is greater than 2 while it is less than 4. So only one number counts for that there. And that would have been 3, but let us write up our numbers here. So we start in probability, we start counting from x equals 0. So we have 0, 1, 2, and 3. So we're counting one less than this value here. So in this case, we are not including 4. All right. I want all the values of x that are greater than 2 while they are less than 4. So only one value we can get there, which is x equals 3. So we're excluding x equals 1 plus x equals 0 plus x equals 2 here. So we're excluding f of 2. All right, so x equals 1. So the probability of x equals 0. The probability of x equals 1. What's the probability of x equals 2? That's the same thing as saying f of 2. And that is what we're excluding here. So minus in that value. And we are not including the 4. So we have f of 3 minus f of 2. And there you go, 4 formulas for cumulative probability distribution created by Noel Powell. All right, I did this formula in 2024. And this all stems from this rule here in cumulative probability. So the probability of x at a certain point. So let's say now we have f of x. So the capital X is the random variable. And the small x is those instances of the random variable. So the probability of x at a certain, so x here, so we are less than. So if we want to find the probability of x at a certain point, we find the cumulative probability. We add up all the probabilities of the numbers that appear before the value of x, also including the value of x. All right, that's what we do. And that will give us our answer here. I hope this table was good for you. So the probability of x less than or equal to a certain value is equal to f of x. So let's say now we want to find f of 3. So f of 3 now is all the probability values of x that come before 3, including 3. All right, so cumulative means we're gathering them together. So it stems from the word accumulate. So we're gathering them together. So f of 3 is equal to probability of x equals 0 plus the probability of x equals to 1 plus the probability of x equals to 2 plus the probability of x equals to 3. And there we go. Hope that this video was insightful for you all.